We just talked about the normal approximation of the binomial. Let's do a couple problems now. So page 129 or so, we have problem number 1. Some vote is scheduled for tomorrow and it looks close. We're to assume that the number of yes votes follow a binomial distribution and that we expect 300 people to actually vote in this, whatever this is. Suppose that the probability that a typical person will vote yes is exactly 0.53. So part A says to identify n and pi for this binomial random variable. So let's go over to the sketchpad and do exactly that. So n is 300 people and pi is going to be 0.53, which is the probability that someone votes yes. Now, in an election, you have to have over half voting yes for the thing to pass. So in this case, notice that 53%, if we could do a complete census, 53% would vote yes, so the thing should pass. This is greater than 0.5, so it should pass. All right, so that's definitely part A. Let's go on. Part B reads, what is the mean and the standard deviation of the number of people who will vote yes? So the word number is italicized, and that's because that's giving us a hint that this question is asking about a count, a binomial count as opposed to a percentage. So let's go right here, part B. XB is the number of yes votes out of the 300 who show up tomorrow. Now we're to find the mean and the standard deviation of this. So the mean will be this. The expected value of XB, remembering your binomial formulas, is just n times pi. So this is 300 times 0.53, and we have 159. So we expect 159 people out of the 300 to vote yes. Now the standard deviation of XB, recall, is n times pi times 1 minus pi, all square rooted. So I'm just going to write that in. So n times, that's a times symbol, 0.53. Then 1 minus 0.53 is going to be 0.47. And if you do the math, this works out to be about 8.645. So I'm going to go draw this. The exact distribution is going to be binomial, but it is approximately normal. And we know it's approximately normal since n times pi is 159. It's a whole lot bigger than 5. N times 1 minus pi is also going to be way bigger than 5, so it's a reasonable thing to assume a normal distribution. Now, in the next part, we're asked to find the probability that a majority will vote yes. So note that if we have 300 people voting, then we need 151 people for a majority. So 150 is just half. It's not quite a majority. We need 151. So in part C, if we want to find the probability that the thing will pass, we're going to find the probability that we have this XB being greater than or equal to 151. So we got to be very careful with our equal sign. So 151 does count. Now let's go work on our normal distribution. The mean was 159. The standard deviation was 8.645. And somewhere out here, I'll put it about right there, is the value 151. So if we had bars, everything to the right of 151 would count. Instead, we're going to use the normal distribution. So let's picture a bar of width 1 centered at 151. Now notice this bar doesn't start at 151. Instead it starts at 150.5. So we're going to approximate this area with the area under the normal curve. So this area is going to run all the way from the edge of this bar on over. All right. Now again, we haven't counted some part that we should, but we're going to count some part here that we probably shouldn't. We shouldn't. So what we'll do is we're going to say that this is just approximately equal to the probability that we have a z greater than, now we can be sloppy with the equals part here, 150.5 minus the mean. Well, the mean is 159. Divide by the standard deviation, which is 8.645. Now if you do the math, this is equal to about minus 0.98. Go use norm_s_dist in Excel, and you'll find that the answer is 0.8373. So there is about an 84% chance that we will come to the right conclusion. The right conclusion being that the thing will pass. There's some probability that based on who shows up at the polls, this thing won't pass when in fact majority do favor it. Let's do the last part, which is part D. Part D reads, now assume that 1,000 people vote, and repeat the previous parts, continuing to assume that pi is 0.53. So part D, we now have an n of 1,000 equals to 1,000. Pi remains 0.53. In this case, the expected value of xb is going to be 1,000 times 0.53, which is equal to 530. So we expect 530 yes votes. The standard deviation of xb will equal, so 1,000 times 0.53 times 0.47, which is 1 minus 0.53. And this works out to be about 15.78. I'm going to go draw it. So again, this is definitely approximately normal. The mean of this distribution will be 530. And we need to evaluate the chance that a majority will vote yes. So let's think about what a majority means in this case. We have 1,000 people voting, which means that we need to have at least 501 people voting yes for the majority to carry. So we need to find the probability that xb is greater than or equal to 501. Well, again, we're going to use the normal approximation, so we're going to say that this is just approximately equal to the chance that we have a z greater than. Now, what are we going to use? Somewhere out here is the value 501. And we should picture a bar of width 1 centered above that value. Now, where does that bar begin? So this is the area that we're trying to find. You're going to see that that bar begins at the value 500.5. So we're going to say we have to find the probability that z is greater than 500.5, okay, minus the mean. The mean in this case is 530. Divide by the standard deviation, which is 15.78. Now if you do the math, this is a minus 1.87. Go look that up using norm_dist. And you'll find the probability is 0.9692. So the area in that whole region is about 97%. So there's a 97% chance that based on who shows up at the poll, this thing will carry as it should. Now, one thing to note about this is the effective sample size. So in the first part, you only had a sample of size 300, and there was a substantial chance, about a 16% chance, that you would come to the wrong conclusion. With a sample of 1,000, that drops to only about 3%. So the power, this is going to be related to a concept called the power of this test, increases as the sample size grows. It would be a good idea to also find these with binom dist in Excel, and what you'll see is that these probabilities, while they're approximate, are really quite close.